Thank you, sir.
Hello again. And thanks again to Mario, to Michael, and to Kat. I love the GitHub integration. The last project I did, I actually was like, oh, I can actually just install Claude Code into a GitHub code space, and all of a sudden I have Claude Code against the repo that I've already been building. It was really great to hear from each of them and hear all about the exciting work being done with Claude. So to close out the show, I'd like to dive a little bit deeper into Claude 4, our research direction, and what developers can expect next from Anthropic. So please help me welcome back to the stage Dario for our one-on-one conversation. Welcome back, Dario.
Hello again.
This is great. This is like our one-on-one in front of the whole audience. This is great. So Claude 4 is out. Claude Sonnet 4 and Claude Opus 4 are available. What excites you the most about the Claude 4 models, and how does it change your thinking about what's possible in the next 12 months?
Yeah, so I think abstractly the thing I'm most excited about is, every time you have a new class of models, there's like more you can do with it, right? So, we're going to be releasing models after Claude 4. There'll probably be a Claude 4.1 at some point, just like we did with Sonnet 3.5. And I think we're just at the beginning of what we can do with the new generation of model. In terms of tasks, I think the autonomy is going to go much further than it has already. Just the ability to set your model free and give it the ability to, do something for a long period of time. I think we're very much still at the beginning of that. I'm actually increasingly excited about the models for cybersecurity tasks. I mean, you can think of cybersecurity as like a subset of coding tasks, but they tend to be higher end coding tasks. And so I think we're maybe finally hitting the threshold for that. And then as a former biologist, I'm always excited about use of the models for biomedical and kind of detailed scientific research work, which I think Opus in particular is going to be good. Opus in particular, I think, is going to be particularly strong at that.
It really connects, I think, to Machines of Loving Grace. So how does Claude 4 fit into that trajectory overall? I like to joke that people think of Machines of Loving Grace as an essay, and I think of it as a product roadmap for the next few years, and I'm curious how Claude 4 fits into that journey.
Yeah, it was sort of a product roadmap that I wrote without knowing how to actually get to it, and kind of said, all right, guys, this is your work, this is your job. I think we're increasingly thinking about on the biology side of things, and software is part of that, right? Increasing amount, because biology increasingly involves data. It even involved data 10 years ago when I was a biologist. I think more and more of it is going to be, okay, we have these models that know a lot about biology and they can help write code. And so if you're a computational biologist, I think these models will really accelerate what you can do. And we have a number of customers who are trying out the models for these tasks. I guess we'll get to that in a bit.
Yeah, I think one of the first hackathons we did after we released MCP, somebody hooked up MCP to one of those like plotters to do drawing, and so Claude could draw for you. It's actually really fun to like see what Claude draws for itself. But it was like the first moment, it was like MCPs don't just have to be connecting to digital systems; they could also be connecting to the real world. So like when you'll be able to drive lab equipment via MCP, I think is an interesting question for the future.
Soon we'll be able to test Claude by connecting it to a polygraph.
Yeah, I love that idea.
Are you lying?
Who needs interpretability when we have the polygraph? You mentioned that moment where you were, convinced that the Claude written content was human written. Any other breakthrough moments in watching us all, dog food Claude 4, or even try it yourself, that made you realize this model felt different?
I didn't actually understand the details, but like there were several people on our side. There was a moment a few weeks before the model launched where someone said, "Oh my God, this model just like one-shotted this like incredibly difficult performance engineering task," and no model had ever done anything like that before. I will say that there's this almost like superstitious process in the model development where like it somehow all comes together at the last moment, even if the training process is all planned out. Like just some of the model's abilities, maybe it's something about their interaction with people, maybe it's something about like just making it the last bit better matters. Maybe it's people getting used to the model and prompting it. But you always find that the early versions of the model People are struggling to figure out how to use them, and then you finally get to a point, and people are like, this works for me all the time. And there's that alchemy that happens somehow always at the last moment.
If you read the Creativity Inc. by Ed Catmull, he talks about the same process with all the Pixar movies. Like, they're really bad until like 2 days before they're supposed to go out. And I feel the same way about our model. Not that they're really bad, but they're not quite there, and then suddenly they click, and we're like, I can't wait to get this out to people.
It doesn't make any sense, because like the training process is uniform, and you would think that it doesn't work that way, that it's all a rational process, but it's absolutely not.
There's no point on the RL curve where
they come together. It comes together at the last minute. I don't know why.
It's a real moment. Many people in the audience are developers here, and a question that I know has come up internally as people think about how AI is developing is, which parts of the software engineering job will AI take over, and what becomes more important in a world where we have autonomous agents being able to do a lot of software engineering?
Yeah, so probably like many people here, I read with great interest Steve Yeage's blog post a couple months ago, "Revenge of the Junior Developer." He had some similar blog posts. He had some similar blog posts around that. He actually came in to visit us even, and that laid out, I think, the vision of where things are going, maybe even better than I could, which is that we're gradually going to more and more autonomy of the models, right? We had this phase where you would do basically autocomplete. Now there's this thing that I guess people have called vibe coding, then we're going more to kind of like you can dispatch the agents to do things. And I think with Claude Code, we're going to go more in the direction of, you can dispatch the agents to do things, and I'm sure we'll have other product surfaces that allow you to do that as well. And I think we're heading to a world where a human developer can kind of manage a fleet of agents and say, you go off and do this, you go off and do this, you go off and do that. But I think continued human involvement is going to be important for the quality control, to make sure they do the right things, to get the details right. And so, working together on both the models and the product surface around it to get the details right is going to be really important.
I think it's also highlighted to me, it makes the stuff that is inefficient in your work way more painful, because it's taking you away from like this flow of building. And so at least it's made me realize like where we're spending too much time on cross-functional alignment and road mapping, when like we just should be trying to get more building. So it's it's become more painful as the engineering part has been sped up as well. So there's endless debate, around the industry around, bigger models or smaller architectures, which will win in the long run. You're famous for, popularizing and pioneering the scaling laws paper. What's your current take on, the extreme being, is pre-training dead? Is pre-training all that matters still, and its role, relative to post-training?
I mean, without getting too specific, I would say that, the Claude 4 models embody advances in both pre-training and post-training. So we're continuing to see the pre-training scaling laws work the way that they've worked before, and we're also continuing to see continued advances in post-training, and they kind of complement each other. And I think we're going to continue seeing advances in both of those. I think we're also going to continue to scale up. So we have these multiple trends, these multiple sources of exponential growth, and they're all going to compound with each other, right? That's why I think all of this is going to go very fast. One of the reasons I liked Yeage's blog post is that it was someone who was not me repeating the mantra of like, it's only going to be a year or two until these things are like, are basically peers to us.
It's insane that 3.7 was just in February, right? It feels like a year ago, but it was just 3 months ago.
I know it. It feels like it's like, oh, this feels like an obsolete model or something. And it was less. It's like 2.5 months or something. It's like the time scales are compressing. I often say that being in the AI field, I will go on a very brief digression. Being in the AI field, it feels like you're getting on a spaceship leaving Earth at relativistic speeds, and one day you wake up and it's like one day on your spaceship, 2 days on Earth. So you have to take in the news of 2 days. It accelerates, 1 day on your spaceship, 3 days on Earth, and that's just what it feels like being on this ride.
That resonates. I hadn't heard that metaphor before, but it absolutely does. Maybe on the post-training front, one of the things that I got really excited about seeing developed in Claude 4 has been this concept of memory and having the model being able to manage its memory. Maybe talk a sec about why that's important and what that kind of enables.
Sorry, repeat the question.
So like for the model to be able to manage its own memory and be able to handle those long horizon tasks as well.
Yes, we have found that to be very useful. I think one place we found it to be useful is Pokemon, right? Yes. Where the model's able to like remember its state, but presumably it's useful for many things other than just Pokemon. No, I think it's great that the model, just as a human would, like when I'm thinking, I'll write a bunch of notes and then I'll like recall those notes at a later time, or there's just a lot of intermediate work that I have to do. That and models do that to some extent when they reason, when they have like our reasoning traces. But not everything I do can be incorporated in one scratch pad, right? There's like presentations, there's individual documents that I write, and so models are the same, right? The idea for them to kind of be able to create files, to do things with those files, to load data, and to kind of seamlessly interleave those things, right? The one of the new features that we have is this kind of interleaved reasoning and taking actions. And some of those actions can be storing data, recalling data. Again, the affordances that the models have are gradually converging towards the affordances that a human has, which I think is the way that it should be.
One of my mind-blowing moments in Claude 4 so far was we added basically a to-do list scratch pad to Claude Code, and just watching it churn through the to-do list, and then as it thought of more things to do, add to the to-do list, check things off, strike out what was no longer relevant. It really mimicked, I think, how people manage their own work and how they think about completion along the way. And then the interleaved reasoning and tool use as well. I saw a write-up this morning on Mac Stories where it was using a tool, it was an MCP, and it hit a rate limit with the backend MCP server. And because it was doing the reasoning, it was I was like, I probably hit a rate limit. Let me try this other approach to do this as well. And so like that ability to reason and remediate as part of tool use, I think is really powerful. I'd love to touch on race to the top. So safety and capabilities are often, thought of as being at odds with each other, and your thesis is exactly the opposite, in that these two things can move in tandem. I found that very inspiring, and one of the reasons I joined here. But maybe touch on how you think of race to the top.
Yeah, so I think it applies to things from the very mundane and simple and commercial to kind of the grand directions that AI is going in the future. So I think when we talk to customers, we have a number of customers who care a lot about making sure that the behavior of their AI models is predictable, that it's trustworthy, and I think that's aligned with what what we're trying to do in the long term for making sure that models in a more grand sense stay in line with human intent. So there's this nice synergy here, and I think whenever we're able to do so, whenever we think it's reasonable or responsible to do so, we do want to provide tools for the community. So MCP is an example of that. I myself was actually surprised at the pace at which everyone seems to have standardized around MCP. I mean, it was very strange. We released it in November. I wouldn't say there was like a huge reaction immediately, but then within 3 or 4 months, it kind of become the standard. Again, there's this feeling of like being on the spaceship accelerating from Earth and experiencing larger and larger time dilation constants.
Yeah.
Where it's think of like USB and other standards. Think of like standards in the 90s or it would take years for people to converge on something.
Yeah, and even in talking to other participants in the industry around MCP, they're like, we don't want to slow down whatever is working on MCP. Like we do want like some help on steering, but like you've captured lightning in a bottle. Let's make sure it becomes the new protocol and the standard by which we interoperate agents as well. Maybe tied together the race to the top, I loved your urgency of interpretability essay. You have a background in neuroscience as well. Can you talk a little bit about how you see the co-development of interpretability and machine intelligence?
Yeah, so I think 10 years ago, many people thought that neuroscience would tell us about how to do AI. And indeed, there are a number of former neuroscientists in the field. I'm not the only one. There are other lab leaders, some who have that background. And, you know, I found at a high level there's some inspiration, but I wouldn't say I've said, oh, you know, this is how the, you know, this thing we know from the hypothalamus we can use for, you know, for making these models. It's all been pretty much from scratch. But interestingly, things have gone the other way more, which is that using interpretability, we're able to see inside models. And although, of course, they're not made in exactly the same way the human brain is, at a, you know, at a kind of superficial level, there's a lot of differences. A lot of the conceptual patterns we have found inside models, sometimes they then get replicated in neuroscience research. There was something about like high-low frequency detectors in vision that was found via interpretability, via one of the people on Chris Ola's team, and then a couple of years later, a neuroscientist actually replicated it in animal brains. The idea that, for example, vision models separate out, you know, they have one path that tends to correspond to color, and you know, another path that corresponds to brightness or to the boundaries between objects. These seem to be natural distinctions in the world, right? That are kind of there to be discovered. And anytime you have any kind of abstract learning system, whether it's artificial or biological, you kind of discover the same thing. So it's very interesting.
I'm really curious how the circuits paper ends up affecting neuroscience research as well. Let's move into the 5 to 10 year time horizon. To the extent that that is even possible in AI as we move relativistically. Maybe relativistically, it's probably 1 year in real time. When do you think there'll be the first billion-dollar company with 1 human employee?
2026.
Yeah, I absolutely buy that. Yeah. Do you have any advice for people building with Claude for the next year? How to think about building at that frontier as well?
Yeah, I think there's like a lot of very specific things you could say about how to use the models, but I feel like because of this whole like relativistic time dilation thing, this like speeding things up, like almost all the advice is drowned out by like one sentence, which is, or maybe 2 words, which is just be ambitious. Like build something that's greater than you think is possible, and even if it doesn't quite work yet, another model will come out in the next generation, which right now is 3 months, but like probably it's going to go down to 2 months, then 1 month, and you know, then if I want to come up this year, maybe I'll be giving advice that's like, oh, you know, don't build anything today. You know, we're releasing something today, but by tonight it'll be, you know, you won't want to be building with this tonight.
I talked to a founder who started a company 2 years ago in the sort of autonomous AI coding agent space, and he basically tried every single model, and his startup wasn't working. And then it's actually 3.7 where he's like, my startup works now. And it was the same thing of like, this thing that I was trying that was really hard, all of a sudden is now possible.
But hitting your head against the wall actually sometimes can be useful because you put all the other pieces in place, yes, and everything works except the model. And then when the model works, it's almost like you've built something that's like more robust than it needs to be, and that can be like a positive property.
Yes.
So you know, as much as I joke about like, oh, you should just, you know, you can just wait for the next model, actually hitting your head against the wall, as long as it's something that's like almost possible, if it's not like, you know, like 3 years out from what's possible, I think it can actually be productive.
We saw that even with advanced research internally, like our research and cloud skills team had built a prototype of this. The model kind of lost its way. It wasn't good at using tools. And then with 3.7, especially with Cloud 4, I think you'll find that it does advanced research really, really well as well. And it's because we were trying and kind of failing along the way as well.
Yeah, it's almost as if you want to run your startup as like speculative execution against the next model, right? Yes. There's some kind of like, I don't know.
I love that. Yeah, I think that's exactly right. All right, so last question to wrap up. For many of us today who aren't Dario, we couldn't have imagined the progress that AI has made and the rapid pace of change. What are you most excited about for the coming year and then in the next 5 years?
Yeah, so I think in the next coming year, we are going to see incredible things in code. I would refer again to kind of the, you know, taking where we are with Claude Code and where we are with the coding models and going from there to kind of the agent fleets. I think this will have an interesting effect in the world, which is I don't know that we've thought carefully, like from an economic or business perspective, about what happens when the cost of producing software goes down. It's kind of an assumption, an article of faith, that you only make software if it's only worth it to make it if millions of people use it, or at least hundreds of thousands, or maybe tens of thousands. Like you wouldn't make you like wouldn't make a whole piece of software for this event, right? Like you might throw together something, but like when it just becomes really cheap, when it costs you 20 cents to like, oh, let's just throw together something that changes my vision for this particular event or something like that. I think the world is going to be very different when these things can be made ad hoc on a one-off basis in like a few seconds for less than a dollar. What is the role of the developer there? What is the role of businesses? What is the role of startups? And what is the experience of the people using it? I think we don't know the answer to any of those questions. So that's very interesting. On the 5-year time scale, I will return again to biology. I think the biomedical stuff will not be revolutionized in the next year because it's kind of slow to happen. But I hope that 5 years from now we will have vanquished many of the diseases that now exist.
We'll leave it with that. Unfortunately, we do have to wrap up. I feel like we could talk for another 40 minutes. So first, I want to thank Dario for spending time with us today. Thank you, Dario. I also want to thank all of you who are here in person and those watching via live stream. But before we close, I almost forgot one thing. As a special thank you to everyone who joined us today at Code with Claude in person, I'm excited to announce that each of you will receive free access to Max 20X, our highest tier plan for 3 months. So look out for that. I especially love using Max with Claude Code, so you'll be able to do that as well. So we can't wait to see what you build. Have a great rest of your day with the different sessions, and welcome again to Code with Claude. Thanks for coming.
Thanks for coming, everyone.